enabling Inter-VPC and Inter-AWS access with VPC Peering with DevOps consultant Ben Dalton. Ben, welcome to the show. Thanks for coming on and to chat about this.
Thank you, Chris. Thank you, Damien.
For those in the live studio audience, welcome. Get in on the conversation. If you are in the live studio audience, then you can either chat with us via YouTube or LinkedIn or Twitch or whichever venue you're on. We are piping it all into the feed. Welcome. Hello, Stephanie. Good to see you again. And Damien, my apologies for not getting you on the board. I apologize. So Canva currently is broken. This is all, I'm blaming Canva. This is not my fault. Canva is broken right now. I couldn't go in and modify the deck to remove Sean and Shala and Roger, who are not here today, and add Damien, who is here today. But Ben is here to talk about how we would fix this if we were in charge of the internet right now. So let me kick over to the stage Ben's deck. I didn't want to get into the normally we do tell us about yourself and how are things going with you, but you've already got your about me up, so I didn't want to steal your thunder on your deck. So
that's okay.
Let us know about Ben Dalton, please.
Thanks, Chris. Thanks for the introduction. So hi everyone. I see a few hellos in the chats. My name is Ben Dalton, officially Benjamin Dalton, but just Ben is fine. And I'm a DevOps and cloud engineer based in the UK, as Chris has already mentioned. And that is the main reason why the time is different, because I would have probably been online at 11 or midnight tonight if it was your usual schedule.
Wouldn't want to do that to you.
So hence the change in the timing today. So I've worked with AWS for a couple of years now across a few different projects. I have a couple of certifications, including the Solution Architect and Developer Associate. And today I'm going to talk to you about an actual problem that I had on a project, but I'll give you some background on what VPC Peering is and how you set that up and everything. That's all about me. I'll share some more resources towards the end if you're interested in following up. So let's get started. So my question, and some of you already may have experienced this issue, but have you ever needed to access some data or resources in AWS, but you were unable to because it existed in another AWS account or VPC? Well, today I will talk you through how you can save time, effort, and money whilst remaining secure in creating a connection that will allow you to access the data and communicate with resources that live outside of your VPC or AWS account. And by the end of this presentation, you'll have a high-level overview on how you can route traffic between VPCs and enable that cross-network resource access and data sharing. So we can achieve cross-network access by leveraging VPC peering connections. So VPC peering connection essentially enables private connectivity between two virtual private clouds or VPCs. And it's a connection that uses the private AWS private network. So when you connect two VPCs, it's really using the private IP addresses, so the private IPv4 and IPv6 addresses. And you can think of a VPC peering connection like a Bluetooth connection. So one VPC sends a request to connect, and the other one has to accept in order to enable that private connectivity. However, that's a very simple analogy. There's a little bit more to it. And through VPC peering, instances and resources in your VPC and the other VPC can communicate with each other as if they were in the same network. So that's a huge advantage of VPC peering. It's as if all the resources are in your VPC as well, as long as you configure all the security rules and stuff. And VPC peering, another thing is you can do it cross availability zone. You can do it in the same availability zone. You can do it across region and cross AWS accounts. So you might be working in teams where you have multiple AWS accounts and you need to access resources across all of them. So that can help you achieve this. So some of the benefits of VPC peering. So I mentioned that it uses private IPv4 and IPv6 addresses, and It also uses AWS's private network, so therefore you have lower latency. Any data or packets that are sent directly between physical hosts where instances are running. So this is on AWS's infrastructure. Also, because of the private connectivity, it improves your security posture and reduces threats. So the traffic that you share between your VPCs, they never actually touch the public internet. And that's a very important thing when it comes to saving costs and for security as well. You also have another benefit. If you're working within the same availability zone, you don't actually incur any costs for any data transfer. The only thing that you will pay for is if you're doing your traffic is routed across an availability zone or across a region. So if you're thinking of high availability and resilience architectures, there will be some costs associated with that. Some common use cases of VPC peering. So I mentioned you can connect VPC accounts. So that's the main and high level use case for it. You can also share data or transfer data across VPCs. So if you wanted to create a file share network, for example, you can use NFS or EFS. And then in addition to that, you can also, with the combination of VPN connections and VPC peering, you can create a hybrid cloud environment and extend your network to on-premises. So now I'm actually going to talk to you about a problem that I encountered, and this is sort of how I discovered VPC peering back when I was working on one of my projects with a client. So the actual problem was, I was working with a data platform team, and we needed to enable our data analysts to access and explore some data that existed in a different AWS account on an RDS instance. And there was absolutely no cross connectivity set up whatsoever. So we needed something quick and cost effective and secure in order to enable them to actually access this data so that they can explore it and find the relevant use cases for the data. So we solved this by setting up a VPC peering connection, and I'll now walk you through the steps that you would do to actually set up a working peering connection. So in this scenario, we have the VPCB on the right, which is our AWS account, and then VPCA on the left, which was the other account's VPC, and the data existed in this RDS database on the left. So the first thing we did is we initiated the VPC peering connection from our account to the other account. So one thing you can notice, if you are doing cross account or cross account and cross region VPC peering connections, then when you initiate a VPC peering connection, you have to get someone to accept it from the other end. So you can't just automatically plug into someone's VPC, because that would be very worrying, right? So in this case, we asked them to accept the request. And once the request is active, you have a working VPC peering connection. But in order to access all the resources within, you need to tell AWS how to route your traffic. So if you're familiar with route tables, they basically hold routes. All of these tell AWS how traffic from your subnets and VPCs should be routed throughout the network. And as you can see, we have a target in each route table as a VPC peering connection, and the CIDR range. If you look right next to VPC peering connection, the CIDR range is of the other VPC. So we put in a route with the other VPC CIDR range, and that tells it any traffic that's going for that CIDR, send it through this VPC peering connection that's been created in step 1. The next thing you would do, and in this case, this will obviously vary depending on your use case, you will update your security group rules. So in this instance, we had a glue connection, which had a security group attached to it, and the other account had an RDS instance with a security group attached to it as well. and we needed to tell the RDS instance to accept inbound requests from our glue connection. And once that's set up, then you have working connectivity. So our analysts were essentially able to query against the data in the RDS database as if it was in our VPC.
So how does that peering request show up within the AWS console?
So it shows up, if you're familiar with the console, if you go into VPC, there is a section called peering connections. And essentially in there, you just have a list of your peering connections. If there is a request, it shows it status pending, and you have the option to accept or reject. I believe it stays pending for 5 days, I may be mistaken, until it actually goes into, I think it's deactivated state. Then you'd have to send another request. But once it's accepted, then it becomes active.
When you were going through this exercise, did you was this manual? Did you automate this process? How did you connect them? How would you connect more in the future?
So I automate everything. So I use Terraform for this. Actually, I use Cloud.
Great answer.
Yeah, I don't believe in writing things twice. So, and also you want to be able to control and redeploy stuff if things go wrong, right?
Mm-hmm.
Yeah. So yeah, I use Terraform on CloudFormation. I can't actually see the chat because I'm actually looking at my own presentation. But let me know if there's any questions that.
There was one quick question. Does establishing VPC peering connection add a route table entry for every subnet in the peered VPCs, or maybe just the main route tables for the VPCs?
Can you repeat that again? Sorry.
Does establishing VPC peering connection add a route table entry for every subnet in the peered VPCs, or maybe just the main route table for the VPCs? Is it manual or is it automatic?
So VPC peering connections, they don't actually do any of the route table stuff for you. You have to go in and do it yourself. So you have control over what subnet siders you want to be available or accessible. In most cases, you would put the entire VPC. In other cases, you might want to restrict it to a subnet. And I'll talk a little bit about that later, about some other more suitable solutions for these specific scenarios.
Awesome.
Right here. So VPC peering is not always the best solution for accessing different resources across VPCs. So there are certain scenarios where you may not be able to use VPC peering, or VPC peering may not be the best solution. So I've mentioned that VPC peering enables private connectivity between VPCs. And immediately you might think, okay, well, if it enables private connectivity between my VPCs, it's essentially exposing the whole network. And if you only want to expose a few applications, maybe one application, two applications, and even just exposing the subnet is a bit too much, then you may not want to use VPC peering because it's a bit overkill. Overexposure is not really good in terms of security. So in that scenario, you may consider something, maybe Private Link, for example. Private Link, it tackles two problems. One, if you want to connect directly to another resource or application in another VPC and just that one. And two, if your VPCs have overlapping siders, then it allows you to connect to that VPC as well, to resources in that VPC. VPC peering is not possible when you have overlapping siders. So that's another limitation. And Private Link can help you solve that problem. If you want to connect multiple VPCs together, and I really like this diagram because VPC peering is not transitive. So if you connect VPC 1 and 2, and then VPC 1 and 3 together, VPC 2 and 3 are not automatically connected. You'd have to set up another VPC peering connection for that. So you can kind of see how managing lots of VPC peering connections will become cumbersome. You have maybe lots of route tables to update, as we saw, lots of routes to enter. lots of VPC peering connections. And if this continues to scale, then it can be quite difficult to manage. The surprising thing, though, is that you can have up to 50 active VPC peering connections, according to AWS's quota. So whilst it's possible, I don't think it's recommended.
You could, but you don't want to.
Yeah, so I would only advise a few accounts. Maybe if you just want to access, a couple of applications or resources in another VPC, or you have other teams that you work with closely. So another thing, you can use transit gateways to solve that issue. So you have lots of VPCs, you get centralized routing and segmentation and large-scale VPC connectivity, and it's transitive, as in you attach each VPC to the transit gateway, and essentially with a VPC attachment, and essentially once the routes are updated correctly, each VPC can communicate with all the other VPCs in a sort of hub and spoke model.
Is there a magic number that, or a throughput amount that you would consider, like, okay, I'm going to use peering up until this point, but now that I have this many things, now I'm going to flip over to transit gateway, or is it a harder decision to make?
I think it could be very dependent on your use cases, but I would say certainly no more than 10. When I worked with one of the clients, I think we had 3 or 4, and I think that was plenty. If we did need to scale beyond 10, then I would have definitely proposed using transit gateways and looking to see how transit gateways could benefit us more. But definitely the administration and management of VPC peering connections could be quite a lot once you scale into the tens of VPCs.
Right.
Yeah.
And did I hear that correctly? You said that VPC peering is not transitive, but that transit gateways are transitive, or did I mishear that? No,
that's correct. So with transit gateways, you can specify which VPCs you want to be able to access other VPCs. So
but it's still not by default. Everything can see everything immediately once you hook everything up. You still have to.
Yeah, you still have some route table stuff to configure, but essentially, you do it from one centrally. You do it from a central place.
I can hear all of our security-minded viewers immediately freaking out at something like that. What? Everything can talk to everything? No, shut it down.
No. You still have to tell it what can access what.
Great.
So you still have control over that.
Awesome.
So I think I mentioned. Yeah, I did mention private link. So I think, so you have other things to consider in terms of your use cases. You have transit gateways, you have private links. You also could consider VPC endpoints. I don't know too much about VPC endpoints, but it's possible to link up different resources and applications like S3 and DynamoDB. You have interface and gateway endpoints. That actually concludes my presentation. So we talked about what VPC peering is. It's a networking connection that enables private routing between two VPCs. So nothing goes over the public internet, therefore increases your security, reduces threats. You get better performance because it uses AWS's private network. And the common use cases we spoke about is if you want to do some sort of data transfer, you want to connect a few VPCs. We've seen that it's relatively simple to set up. You have the VPC peering connection to update the route table, and then depending on your use case, you would update a security group rule, for example. And any traffic that's routed within your availability zone is free. You pay for cross-availability zone and cross-region traffic. And finally, which I might emphasize, is you should only consider VPC peering if you're looking at a few VPCs, because AWS has created other services to manage a whole host of VPCs that will make your life a lot easier. And then finally, if you have overlapping VPC siders, then VPC peering is just not possible. So if there's anything you take away from today, I would say consider VPC peering if you're doing, I don't know, a little bit of testing, or you have like maybe one or two teams you want to work with. And also you have assurance that your traffic is on the private network and you are not exposed to these common exploits such as DDoS attacks, for example. And yeah, that's me. Thank you. So if there are any questions, feel free to ask. I've written a blog about this, where I use CloudFormation to deploy a whole solution, as well as some instances to show you how once you set it up, you can actually ping or send traffic through cross VPCs. I've got the QR code here. So on there, you'll find my LinkedIn, my GitHub, and the Medium article that I just mentioned.
Do you have the link that we can put up in the chat channel as well for the article?
Yes.
I was just about to ask. I know that you did it for a customer, so you probably don't have. But do you? So you have the code available, so people can play with this as well to set up and automate VPC peering connections in that article.
Yep, it's
Awesome.
It's linked to my GitHub, so you can see the
Wonderful.
CloudFormation templates in there. I decided to do CloudFormation because I hadn't really used it that much, so it's kind of like a learning exercise for myself.
I'm not going to hold that against you. What's your GitHub, Ben?
It's B-Dalton, B-Dalton.
There we go.
Oh, I have all builders welcome alumni.
So I know that it was a bit
awesome.
of a joke, but one of the questions in the chat is, why are we still using IPv4? So can you use IPv6 with VPCs?
That's a good question. Can you use IPv6 for VPC peering? I don't see why not. I believe so, but I don't see why not, because you're essentially creating routes in your route table, and you can use IPv6 when you create routes. So my answer, my guess would be yes, but I've never tried it before.
Yeah, Ben, shoot me the link in the Slack, and I'll post it because StreamYard is very weird about allowing people to post links in there. It doesn't allow anybody to post links except for me. So
Got you.
there is the link to the Medium article. And we'll post this in the show notes as well, so that when people are watching it in the future, the show notes will have the article for setting this up for themselves. So fabulous.
Thank
and
you.
I saw the IPv4 question as well, and I was like, oh, you're right. It is 2024. What is happening here?
Yeah. Well, surprisingly, there's still lots of IPv4 addresses left.
Oh.
I think we just had this scare, and IPv6 was born.
No, there's still absolutely tons of it. I'm an old ancient CCNA, so I cut my teeth on IPv4 back in the day, just as IPv6 was coming out, and yet still to this day, it's has not taken over the world. Was there another question?
I'm actually curious to know who uses IPv6 from the audience.
Yeah, honestly, it's still. I mean, because of the fact that we have NAT gateways and my big thing with VPC peering was back in the day when I was still doing that for customers, we always had to find a very esoteric and unused CIDR block because everybody uses 10 dot or 10.0.1. So we had like 172.16.254.0 just to be able to find a subnet that nobody was going to use, so that we could connect to multiple customers together.
Oh,
Grand fun back in my consulting days.
So according to Wikipedia, yeah, according to an article I didn't just edit,
GPT says that.
So as of May 2024, Google shows IPv6 availability of its global user base in the low to mid 40%. France, Germany, and India run the majority of their traffic to Google over IPv6. US, Brazil, Japan do about 50%. Russia and China have a very low adoption, like in the 10% range. And then countries like Sudan and Turkmenistan have less than 1%. So
wow,
I guess it's a work in progress, right? As long as I've been in technology, I've heard about IPv4 going away. And that's 30 years, right? So, well, maybe not 30, close enough, 25. But yeah, it's been going away forever. But yeah, the rise of IPv6 has been a slow one. But maybe in our lifetimes it'll be at 100%. Who knows?
I doubt it. Amazing. Yeah, Stephanie, we will retire before full adoption.
Hopefully. Good Lord.
Yeah. We'll be like that one COBOL programmer that was brought out for Y2K. Let's fix some code. Oh boy.
So my wife works for a modern software company that runs on COBOL. And it's bonkers how much COBOL still exists in the world. So we'll probably never be completely free of IPv4.
What do you guys still actually do hands-on work or just advisory consulting?
So I got out of consulting. I've been doing advisory and consulting for about 10 years until I flipped over to DevRel for HashiCorp. And so now I've been doing DevRel for a year and a half. But I mean, honestly, they hired me because of things like this podcast and my articles and my user groups and stuff like that. So they asked me to come on and do what I was doing for free at night as my hobby, to come and do that for HashiCorp as a day job for a paycheck. Yes. And so I was like, sold. I am immediately in. It was like a dream job for me. Had I not done that, I would still be in consulting. I'd still be, working for, fortunes and putting out fires.
That's really cool. So what is you said DevRel?
Yeah, developer relations. Effectively, it's a branch for HashiCorp. It's a branch of the marketing arm, but it does. It depends on like which. So developer relations and developer advocacies. You hear the terms like avocado sometimes. So depending upon the company, they have similar functions, and my job is to go out into the community and talk about the cool things that I've done for HashiCorp with HashiCorp tools, and basically tell old war stories and have cool fun demos and play with customers stuff. So yeah, much less high pressure than what I was doing.
It doesn't sound like you're working at all, just having fun.
It really is. It's amazing. I absolutely love this job.
Yeah,
that's enough. Ben, this was your show. What are you doing here? All right,
I'm interested.
Ben Dalton.
My first VPC talk, so I'm interested as well.
Yeah, so vBrownBag is not HashiCorp affiliated, but they like me doing it, so they're like, yeah, keep on doing it. I'm like, okay,
nice.
So Ben, thank you so much for coming on. Appreciate you staying up later into the evening, your time.
Thanks, everyone.
All right,
thanks.
Bye, team. Thanks a bunch.
Bye.